This session we will be talking about application of derivatives, and in application of derivatives we need to learn the following subheadings: tangents and normals, monotonicity, maxima minima, and mean value theorems. Let us look at the first subheading, tangents and normals. If you look at the meaning of the derivative, derivative corresponds to rate of change, and consider a graph y is equal to f of x. As x coordinate changes from x1 to x2, the y coordinate changes from f of x1 to f of x2. And if you look at the change in y coordinate, that is the ordinate, it is f of x2 minus f of x1 divided by x2 minus x1, where x2 minus x1 is change in the abscissa and f of x2 minus f of x1 is the change in the ordinate. And if we look at this expression, this is nothing but slope of this line. It is slope of the chord y2 minus y1 by x2 minus x1. We also know that any chord or a secant, the limiting condition, it becomes a tangent. As x1 tends to x2, that is, as this point moves closer and closer along the curve, this chord, it tends to become a tangent at the point x2. So, when we apply limit x1 tending to x2, as this point here moves closer and closer to this point, the secant, it becomes a tangent at x2. So, slope of the secant, it will become slope of tangent at x2. So, simply we can say derivative f dash of x gives tangent of inclination, that is slope, at any point x on the curve. So, in this chapter we will be talking about how to make use of f dash of x in terms of finding tangents and normals. Let us say we have a curve y is equal to f of x, and our target is to find tangent at a point whose coordinates are x1 and y1. Now, in the previous discussion we have learned that this tangent slope of the tangent is given by f dash of x1 for any differentiable curve for which f dash x exists. Slope of the tangent at any point x1 comma y1, it is given by f dash of x1, that is dy by dx at the point x1 comma y1. So, slope of the line is known, the tangent line, and also the tangent line passes through the point x1 comma y1. So, we can write equation of the tangent as y minus y1 is equal to slope is f dash of x1 into x minus x1. Y minus y1 is equal to f dash, derivative of the curve dy by dx at the point x1 comma y1 into x minus x1. Here we are using the slope point form of a straight line. Slope of the tangent line is f dash of x1 and it is passing through the point x1 comma y1. So, equation of the tangent would become y minus y1 is equal to f dash of x1 into x minus x1. Similarly, if slope of the tangent is f dash of x1, slope of the normal would be minus 1 by f dash of x1, that is minus 1 divided by f dash of x1, that is because tangent and normal, they are perpendicular to one another and product of the slopes is minus 1. So, as tangent slope is f dash of x1, normal slope would be minus 1 by f dash of x1. We can also find equation of the normal. We know slope of normal, it is minus 1 by f dash of x1, and we know normal also passes through the point x1 comma y1. Normal is a line passing through the point of contact and perpendicular to the tangent. So, equation of the normal would be again using slope point form, because it passes through x1 comma y1, y minus y1 is equal to m, which is slope of the normal, minus 1 by f dash of x1 into x minus x1. So, equation of normal, it is given by y minus y1 is equal to minus 1 by f dash of x1 into x minus x1. So, this is how we find equation of tangent and equation of normal at any point on a curve which is differentiable. So, let us again see, to write equation of tangent at any point x1 comma y1, slope of the tangent would be f dash of x1 for any curve which is differentiable. Slope of the tangent would be x1 comma f dash of x1, and equation of the tangent would be, we use slope point form of straight line, y minus y1 is equal to m, slope of the tangent line, which is f dash of x1 into x minus x1. This is the tangent equation. And how to write the normal equation? Normal equation is again we use slope point form. Normal is a line passing through the point of contact and perpendicular to tangent. So, it passes through x1 comma y1, y minus y1 is equal to m into x minus x1, and slope of normal would be minus 1 by f dash of x1, where f dash of x1 is slope of the tangent line. So, this is how we write equation of tangent and equation of normal at any point on the curve using application of derivatives. That is the reason tangents and normals can be ably dealt in the chapter of application of derivatives. Let us look at an example. Let us say we are asked to find tangent to the curve y is equal to sin x at the point whose x coordinate is pi by 4. At the point whose x coordinate is pi by 4, we need to find the tangent to the curve. Let us see, we all know the graph of sin x. This is how it would be between 0 to pi. We want tangent line at the point whose abscissa is pi by 4. Its ordinate we know, sin pi by 4, 1 by root 2. We want to find the tangent equation. So, tangent equation is given by y minus y1, y coordinate at this point is pi by 4 comma 1 by root 2. Y coordinate at this point is 1 by root 2 is equal to m. M is slope of the tangent line, and slope of the tangent line we use differentiation to get it. Slope of the tangent line, it is given by dy by dx f dash of x. Dy by dx for this curve it is cos x, and at which point? At x equal to pi by 4. At x equal to pi by 4, cos x is also 1 by root 2. So, slope of the tangent is 1 by root 2 into x minus pi by 4. So, equation of the tangent, it is given by y minus 1 by root 2 is equal to 1 by root 2 into x minus pi by 4. So, this is how we find equation of tangent to any curve. Let us look at another example. Let us say I am asked to find tangent to the curve x square is equal to 4by, x square is equal to 4by at the point 2bt comma bt square. At the point 2bt comma bt square on the curve x square is equal to 4by, I am asked to find equation of the tangent. Now, we can see for all values of t, this point satisfies this curve. Let me substitute bt square here in place of y. It is 4b square t square in the right hand side 2bt here, 4b square t square in the left hand side. These are called parametric coordinates of any point on this particular curve. So, let us find equation of tangent at this point. Equation of tangent at this point, it is given by y minus y1, y coordinate at this point is bt square is equal to m into, m is dy by dx at this point. Dy by dx, I can either differentiate this curve or differentiate the ordinate and abscissa here parametrically with respect to t. So, dy by dx is dy by dt, which is 2bt divided by dx by dt, which is 2b, 2b gets cancelled, dy by dx at any point on this curve is nothing but t into x minus x1, x1 is x coordinate at this point, which is 2bt. So, equation of the tangent, it is given by y minus bt square is equal to t into x minus 2bt. We can simplify this further. Y equal to xt minus bt square here, minus 2bt square here, 1 minus bt square gets cancelled and minus bt square. So, equation of the tangent at any point whose parametric coordinates are 2bt, bt square on the curve x square is equal to 4by, we can say it is y is equal to xt minus bt square. Let us look at another example. On the curve x square plus y square is equal to a square. At the point a by root 2 comma a by root 2, find equation of normal. We are asked to find equation of normal at the point a by root 2 comma a by root 2 on the curve x square plus y square is equal to a square. So, let us look at the curve x square plus y square is equal to a square. A point is given on it a by root 2 comma a by root 2. A is a constant here. We are asked to find normal. Equation of normal, we know it is given by y minus y1, y coordinate at this point a by root 2 is equal to m into, m is what? Dy by dx is slope of the tangent. So, minus dx by dy will be slope of the normal. So, let us find what is slope. Differentiate the curve. 2x dx plus 2y dy is equal to 0. Derivative of x square is 2x dx, y square is 2y dy, a square is a constant, it is 0, which implies dx by dy, take dy the other side and bring it back, dx by dy is equal to minus y by x, or minus dy by dx by dy is equal to y by x, minus dx by dy is equal to y by x. Now, here we can see y coordinate is a by root 2, we are bothered about minus dy dx by dy at this particular point, where y coordinate is a by root 2 and x coordinate is also a by root 2. So, a by root 2 by a by root 2 gives slope 1. So, slope of the normal is 1 into x minus x1, x minus x coordinate at the point is also a by root 2. So, equation of the normal, it is y minus a by root 2 equal to 1 into x minus a by root 2, or a by root 2 gets cancelled, y is equal to x. So, it is a line passing through origin and having slope 1. This we can verify. Normal of a circle x square plus y square equal to a square is a circle, and we all know normal at any point on the circle passes through the origin. So, this is also a line y equal to x passes through the origin and having slope 1. So, equation of normal is y is equal to x. Let us look at another example. Find equation of normal at any point at square comma 2at, point is again given in terms of a parameter t, at square comma 2at on the curve y square is equal to 4ax. We can see for all values of t, this point satisfies this curve. At square, when we substitute, it is 4a square t square in the right hand side. 2at, when we substitute, again it is 4a square t square in the left hand side. So, this is a point on the curve. Now, we are asked to find equation of tangent at this particular point. We have to find equation of normal at this particular point. This angle is 90 degrees. Now, equation of normal, it is given by y minus y1. Y coordinate at the point is 2at is equal to m into, let us come back to slope, x minus x1 x minus at square. X coordinate at this point is at square. Now, how to find slope? Slope is given by minus dx by dy, minus 1 by dy by dx, minus dx by dy. Let us differentiate this. 2y dy by dx is equal to 4a, or dy by dx is equal to 2a by y, and y coordinate is 2at at this particular point. So, 2a by 2at, it is 1 by t. So, dy by dx is 1 by t, slope of tangent is 1 by 3. So, slope of normal would be minus t, minus dx by dy would be minus t. So, equation of normal, what will it be? Y. Let me bring this minus tx the other side, plus tx is equal to, let us push this 2at the other side, 2at plus at cube. So, equation of normal at any point at square comma 2at to the curve y square is equal to 4ax, it is given by y plus tx is equal to 2at plus at cube. Let us now see the concept of finding lengths of tangent, normal, subtangent and subnormal using application of derivatives. Before that, let us discuss what is length of tangent, what is length of normal, what is length of subtangent and what is length of subnormal. Take any curve. Let us say at a point P x1 comma y1 on the curve y is equal to f of x. We want to discuss what is length of tangent, what is length of normal, what is length of subtangent and what is length of subnormal. Let us draw tangent at the point P. And let us say this tangent cuts x-axis at the point T. Let us say tangent at P cuts x-axis at T. So, the length PT, it is called length of the normal, length of the tangent. The length PT, where the tangent at P cuts x-axis at T, this portion of length, it is called length of the tangent. To find what is length of normal, draw normal at P. Draw normal at P. Let us say normal at P cuts x-axis at N. Normal at P, let us say it cuts x-axis at N. Then the length Pn, it is called length of the normal. So, whenever we are drawing a tangent at P, if it cuts x-axis at T, the length Pt, it is called length of tangent. Whenever we are drawing a normal at P, if it cuts x-axis at N, the length Pn, this entire length, it is called length of normal. And we know this triangle, it is a right angled triangle. Then let us see what is subtangent and subnormal. Take a curve. Let our discussion be at the point x1 comma y1 on the curve. For subtangent, draw tangent at P and let the tangent cut x-axis at t. Now the projection of PT is length of the tangent, projection of PT on x-axis, projection of PT on x-axis, that is draw a perpendicular from P onto x-axis. Let us call this point P dash T. Let us call this point P dash. This P dash T is called length of subtangent. So length of subtangent is projection of length of tangent on x-axis, or in simpler words, draw perpendicular from P onto x-axis. Let's say the foot of the perpendicular is P dash. The length P dash T is called length of subtangent. So we have to visualize them and keep them to memory. To find length of subnormal, draw normal at P. Draw normal at P. Let's say the normal cuts x-axis at n. The length of Pn we already discussed, it is called length of the normal. Projection of length of normal, projection of Pn on x-axis, it is called length of subnormal. Length of subnormal is projection of Pn on x-axis. P dash of n, it is called length of subnormal. So subtangent and subnormal are projections of tangent and normal on x-axis respectively. So P dash T, where P is foot of the perpendicular from P onto x-axis, P dash T is called length of subtangent, and P dash N is called length of subnormal. Let's exercise all these terms once again. For any curve, if our discussion is at the point P x1 comma y1, let us draw tangent at P to cut x-axis at T. The length PT, it is called subtangent. The length PT, it is called length of the tangent. Let us draw normal at P to cut x-axis at N. The length Pn is called normal, or length of normal. This is tangent length. And to get subtangent, let's draw projection of P on x-axis, let's say at P dash. The length P dash T is subtangent, and the length P dash N is subnormal. So let us find all these lengths in terms of this particular length PP dash. PP dash is nothing but ordinate of the point y1. So this length, we say it is mod y1. PP dash is mod y1. Ordinate y1 is ordinate of the point. Let us find subtangent, subnormal, normal and tangent at all these points. This length is mod y1. Let us call this angle theta. Tan theta, or let's bother only about the absolute value of tan theta. Tan theta, modulus of tan theta will be same as modulus of this slope of this line, and this line is tangent. So modulus of tan theta, we can get it by from slope of the tangent, and slope of the tangent, it is f dash of x1. Slope of the tangent, it is f dash of x1. So modulus of tan theta, it is equal to modulus of f dash of x1. Let us also call this term m. So for easy reference, we can call this term m. Modulus of tan theta, it will be equal to modulus of f dash of x1. Let us call this term m, slope of the tangent. Now if you look at the triangle PTP dash is a right angle triangle PTP dash. We know side opposite to theta it is mod y1. Side opposite to theta is mod y1. So adjacent side it is given by tan theta is opposite side by adjacent side. Tan theta is opposite side by adjacent side. So adjacent side it is given by mod y1 into cot theta. So subtangent length P dash T it is given by mod y1 into cot theta. Tan theta is m, so cot theta will be 1 by m. So P dash T is equal to mod y1 by m. Length of subtangent is equal to mod y1 by m, where y1 is ordinate of the point and m is dy by dx at that point. So length of the subtangent we can say it is equal to modulus of y1 by m. The mod is for the entire expression because length has to be positive. Now look at this hypotenuse. Opposite side by hypotenuse is sin theta. So hypotenuse it is given by mod y1 into cosecant theta or mod y1 by sin theta. So length of the tangent it is equal to mod y1 by sin theta. Sin theta what would it be? Tan theta divided by, goes on to the numerator, secant theta, which is 1 plus m square. So length of the tangent we can say it is mod y1 by m root over 1 plus m square, where m is dy by dx at that point and y1 is ordinate at that point. Let us look at it once again. Observe the triangle P dash T. Mod y1 ordinate is opposite side to theta and length of the tangent P dash pt is hypotenuse of this triangle, and hypotenuse we know it is given by opposite side into sin theta, opposite side divided by sin theta, and sin theta value is tan theta by secant theta, which is m, and here root over 1 plus m square. So length of the tangent it is mod y1 by m root over 1 plus m square. Now for the subnormal and normal we have to focus on P dash n triangle. Let us look at it. Let us redraw the figure. We are observing length of tangent, subtangent, normal, subnormal at the point P. For tangent we have drawn the tangent to cut x-axis at t. This angle we called it theta. Slope of the line tan of 180 minus theta, tan theta are same in magnitude. Now our focus is on length of the normal. Pn is length of the normal. We have drawn projection from P onto this line P dash. Now this is a right angle triangle. If this angle is theta, this angle would be 90 minus theta. That makes this angle theta. P dash n and P dash t are similar triangles. This angle being theta, this angle will also be theta. Now let us observe this triangle. We know P dash, we called it mod y1, ordinate at the point P. P dash n, opposite side by adjacent side we know it is tan theta. So tan theta is P dash n divided by mod y1, or P dash n, length of the normal, it is equal to mod y1 into tan theta. Mod y1 into tan theta. Tan theta we called it m in this case. So it is mod y1 into m. Length of the normal it is given by mod y1 into m. Opposite side to theta divided by adjacent side will be tan theta. So opposite side it is given by adjacent side into tan theta. So P dash n, our subnormal, it is given by mod y1 into tan theta, which is mod y1 into m. So length of the subnormal we can say it is equal to mod y1 into m. Now we are left with finding length of the normal. Length of the normal is Pn. Observe the triangle P dash n. It's a right angle triangle and Pn is the hypotenuse. So adjacent side mod y1, hypotenuse is what we have to find. So hypotenuse is given by mod y1 into cos theta. Sorry, mod y1 divided by cos theta. Hypotenuse is given by mod y1 divided by cos theta. So length of the normal, it is equal to mod y1 divided by cos theta or multiplied by secant theta, and secant theta is root over 1 plus tan square theta, which is 1 plus m square. So Pn, length of the normal, it is mod y1 into root over 1 plus m square. So now we have all length of tangent, normal, subnormal, subtangent in terms of ordinate at the point and the quantity m, which corresponds to dy by dx at that point. So let us look at all these once again. Length of the tangent at any point, it is given by modulus of y1 by m root over 1 plus m square. Length of the normal at any point, it is given by y1 into root over 1 plus m square. Length of subtangent at any point is given by mod y1 by m, and length of subnormal at any point, it is given by mod y1 into m. So let us look at all these terms once again. Length of tangent, it is given by modulus of y1 by m root over 1 plus m square, where m is dy by dx at that point. Length of normal is given by modulus of y1 root over 1 plus m square. The only difference is m in the denominator is not there in tangent, not there in the normal, it is there in the tangent. Length of subtangent is mod y1 by m, the same term as tangent here except for root over 1 plus m square, and length of subnormal is mod y1 into m, mod y1 into m. So these are the terms which have geometric significance with respect to any curve, and to find these lengths we are making use of application of derivatives here, that m is nothing but derivative dy by dx at that particular point. Let us look at an example. To the curve y square is equal to 4ax at the point at square comma 2at, find length of the normal, length of the tangent, length of the subtangent, and length of the subnormal. So let us find length of tangent, normal, subtangent, and subnormal to the curve y square is equal to 4ax at the point at square comma 2at. Let's call this point P. When we draw tangent at P to cut x-axis at T, PT is called length of the tangent. The normal at P, if it cuts x-axis at N, Pn is called length of the normal. When we are drawing a projection of P on axis, x-axis, P dash N is called length of the subnormal, and P dash T is called length of the subtangent. So here our target is to find PT, Pn, P dash N, P dash T. Length of the tangent, we have formula for length of the tangent, normal, subnormal, and subtangent, and all this depend on y coordinate of the point 2at, and also dy by dx at that point. Dy by dx at that point, it is given by what? Dy by dx is dy by dt, which is 2a, by dx by dt, which is 2at. 2a gets cancelled, dy by dx is 1 by t. So m is 1 by t. Let us find pt, length of the tangent. It is given by mod y1 by 1, mod y1 2at by m 1 by t t goes up and becomes t square, root over 1 plus m square, 1 plus 1 by t square, which is nothing but 2at square, root over, take LCM, t square plus 1 by root t square is t gets cancelled, and because length has to be positive, let us put a mod. So length of the tangent, it is mod 2at root over t square plus 1. Length of the tangent pt, it is mod 2at root over t square plus 1. Let us find length of the normal. Length of the normal Pn, it is given by y into modulus of y, 2at into root over 1 plus m square, m is 1 by t, 1 plus 1 by t square, take LCM, 2at root over t square plus 1, root t square is mod t, t gets cancelled, and because length has to be positive, let us put a modulus. Mod 2a root over t square plus 1 is length of the normal. Let us find length of the subtangent. Subtangent, it is p dash of t, this length is subtangent. P dash of t, it is given by y1 by m, y1 by m, which is 2at is y1 by m dy by dx, we got it to be 1 by t. So 1 by t, t goes into the numerator to become 2at square. So length of the subtangent is 2at square, and because length has to be positive, let us put a modulus sign. And then length of the subnormal p dashian, it is mod y1 into m, y1 is 2at into m is 1 by t, t gets cancelled, it is mod 2a. Now we can see subnormal is independent of t, that is, we can say subnormal at any point on the curve, it is of a constant length 2a. Let us look at next example. Let us find length of the tangent, length of the normal, length of the subtangent, and length of the subnormal to the curve y is equal to sin x at the point whose abscissa is pi by 4 and ordinate, obviously abscissa, if it is pi by 4, ordinate would be sin pi by 4 1 by root 2. So at the point pi by 4 comma 1 by root 2, let us find length of the tangent. Draw a tangent, let us say this point is p, let the tangent cuts x axis at t, pt is called length of the tangent. Draw the normal, let us say normal cuts x axis at n, pn is called length of the normal. Projection p dashian is called subnormal, and p dash t is called subtangent. So let us find each one of the lengths. Before that, dy by dx is equal to cos x, and at this point dy by dx would be 1 by root 2, cos pi by 4 is 1 by root 2. So let us find each one of them. Starting with length of the tangent pt, it is given by modulus of y1 by m. Modulus of y1 is y coordinate at this point 1 by root 2 divided by m is dy by dx at that point 1 by root 2, both of them they get cancelled, root over 1 plus m square, m is dy by dx at that point 1 by root 2, its square is 1 by 2. So length of the tangent is root 3 by 2. Length of the tangent is root 3 by 2. Let us find length of the normal Pn. It is y coordinate at that point mod y1, which is 1 by root 2 into root over 1 plus m square. 1 plus m square, just now we have found it is 1 plus 1 by 2, or root 3 by 2, or root 3 by root 2 into root 2 becomes 2. So length of the normal, it is root 3 by 2. Length of the subtangent p dash of t, it is given by modulus of y1 by m. y1 is 1 by root 2 and m is 1 by root 2. So, modulus of y1 by m, it is 1. P dash t is equal to 1. Length of the subnormal P dash n, we know it is y1 into m. So, modulus of y1 is 1 by root 2 and m is 1 by root 2. So, it is 1 by 2. Length of the subnormal is 1 by 2, length of the subtangent is 1, length of the normal is root 3 by 2 and length of the tangent is root 3 by 2. Next point, let us look at angle of intersection between curves. Let us say we are given any two curves, y is equal to f of x and y is equal to g of x. And let us say these two points intersect at, these two curves intersect at a point x1 comma y1. By saying angle of intersection between the curves, we mean angle between the tangents at the point of intersection. Angle of intersection of two curves, it is given by angle between the tangents at the point of intersection. So, let us say we call this angle theta. Tangent of the acute angle between the tangent lines, it is given by modulus of, if say m1 is slope of this line and m2 is slope of this line, from straight lines chapter we know angle between the lines, it is given by modulus of m1 minus m2 by 1 plus m1 m2. So, we use the same concept here. Angle between the tangent lines, it is given by m1 slope of the tangent to one curve at x1 comma y1. It is given by derivative of f of x, f dash of x at x1 comma y1, which is f dash of x1 minus g dash of x1 divided by 1 plus f dash of x1 into g dash of x1. So, to find angle between two curves, first we need to find the point of intersection, and then at the point of intersection we need to find slopes of the tangents to both the curves, and angle between the curves, acute angle between the curves is given by modulus of m1 minus m2 by 1 plus m1 m2. Let us look at it by an example. Let us say we want to find angle of intersection of the curves y is equal to sin x and y is equal to cos x between 0 to pi by 2. Between 0 to pi by 2, we want to focus on angle of intersection of the curves y is equal to sin x and y is equal to cos x. Cos x, we know the graph, this is how it would be, and sin x graph, it varies from 0 to 1, and both of them they intersect in between, and we are asked to find angle of intersection of these two curves, that is angle between the tangents at the point of intersection. So, first and the foremost thing what we need to do is find the point of intersection. Point of intersection is the point where sin x is equal to cos x, both the curves meet, y equal to sin x and y equal to cos x meet when sin x is equal to cos x. And between 0 to pi by 2, we know sin x is equal to cos x when tan x is 1, that is when x is pi by 4. So, abscissa of the point of intersection is pi by 4, and at that point ordinate would be sin pi by 4, which is 1 by root 2. So, point of intersection is pi by 4 comma 1 by root 2, and at this point we want to find angle between the curves. Let us say m1 is slope of tangent to the curve cos x and m2 is slope of tangent to the curve sin x at the point pi by 4 comma 1 by root 2. Now, m1 is given by differentiate cos x, derivative is minus sin x. At the point pi by 4 minus sin x is minus 1 by root 2, and m2 is slope of tangent to sin x, differentiate sin x, derivative is cos x. At pi by 4 it is plus 1 by root 2. So, m1 is minus 1 by root 2, m2 is plus 1 by root 2, and angle between the curves tan theta, it is given by modulus of m1 minus m2 minus 1 by root 2 minus 1 by root 2 by 1 plus mod m1 m2, 1 plus m1 m2, which is minus 1 by root 2 into root 2, 1 by root 2. So, tan theta it is given by m1 minus m2 by 1 plus m1 m2. m1 is minus 1 by root 2, m2 is 1 by root 2. So, tan theta here we have. Modulus is there. So, we can remove the minus signs here. 1 by root 2 plus 1 by root 2 is root 2. 1 by root 2 into 1 by root 2 is 1 by 2. 1 minus 1 by 2 is 1 by 2. So, tan theta it is equal to 2 root 2. So, angle between the curves it is tan inverse 2 root 2. Angle between the curves is tan inverse 2 root 2. Let us look at another example. Let us say we want to find angle of intersection of the curves y square is equal to x and x square is equal to y. Y square is equal to x, this is how the curve would be, and x square is equal to y, this is how the curve is. They intersect at a point and we are asked to find angle between the curves, which is nothing but angle between the tangents at the point of intersection. So, for this, first and the foremost we need to find the point of intersection. Y square is equal to x and x square is equal to y. We need to solve both the curves. Y is x square, so y square would be x power 4 from one curve and x from the other curve. So, x is either 0 or 1. So, let us find angle between the curves at the point 1 comma 1. At the point 0 comma 0, tangent to y square is equal to x is y axis, tangent to x square is equal to y is x axis. These two tangents are perpendicular. Angle between the curves here at this point is 90 degrees. Such an intersection we call it orthogonal intersection. We will come back to it. Now, let us find angle of intersection at the point 1 comma 1. Angle of intersection at 1 comma 1. So, for that we have to find slope of tangents to both the curves. Let us say for y square is equal to x, slope of the tangent is m1, and for x square is equal to y, slope of the tangent is m2 at the point 1 comma 1. m1 is what? Differentiate the curve. 2y dy by dx is equal to 1 or dy by dx is 1 by 2y at the point 1 comma 1 it is half. So, m1 is equal to 1 by 2. dy by dx to the curve x square is equal to y. dy by dx is 2x and we are discussing at the point 1 comma 1. So, dy by dx is 2. So, slope of the tangent is 2. So, angle between the curves tan theta it is given by modulus of m2 minus m1 2 minus half divided by 1 plus m1 m2 2 into half, which is 2 minus half is 3 by 2 divided by 1 plus 1 it is 2 or this is 3 by 4. So, angle of intersection theta is equal to tan inverse 3 by 4. So, this is how we find angle between two curves at the point of intersection. Then we use a term called orthogonal intersection. Two curves are said to cut each other orthogonally when at the point of intersection the tangents are perpendicular to one another. If angle between the curves is 90 degrees or when tangents at the point of intersection to both the curves are perpendicular to one another, we say the curves cut each other orthogonally. Wherever the word orthogonal comes into picture, it has to do something with perpendicularity or the angle 90 degrees. And here in the concept of angle of intersection of the curves, when we say curves cut each other orthogonally or curves intersect each other orthogonally, that means at the point of intersection tangents are perpendicular to one another. So, if slope of tangent to one curve is m1 and slope of tangent to another curve is m2, if m1 m2 is equal to minus 1, then we say curves cut each other orthogonally. Or f of x is one curve and g of x is another curve. At the point of intersection x1 comma y1, if f dash of x1 into g dash of x1 is minus 1, then we say the curves cut each other orthogonally. We have seen in case of y square is equal to 4ax, we have seen in case of y square is equal to x and x square is equal to y, tangent at 0 comma 0 to y square is equal to x is y axis, and tangent to the curve at 0 comma 0 to x square is equal to y is x axis, and because these two tangents are perpendicular to each other, we say the curves y square is equal to x and x square is equal to y cut each other orthogonally at the point 0 comma 0.